Principles of data, engineering, architecture. Make reversible decisions. This principle means designing systems and making architectural choices that can be changed or rolled back with minimal cost or disruption if requirements or circumstances change. Key points: experimentation-friendly. Design systems that allow experimentation, such as testing new databases or pipelines without impacting the whole architecture. Avoid overcommitment. Don't commit early to technologies or tools that lock you in. Keep your architecture flexible. Use feature flags. Implement new features behind feature flags so they can be easily rolled back if needed. Build in isolation. Develop components as isolated services, microservices, so changes in one don't break others. Choose open standards. Prefer open source or standards-based tools to avoid vendor lock-in. Keep interfaces stable. Maintain stable APIs and interfaces so back-end changes don't affect consumers. Automate rollbacks. Use CI/CD pipelines with rollback mechanisms in case of deployment failure. Document assumptions. Record why decisions were made to reassess them later if conditions change. Use infrastructure as code, IAC. Tools like Terraform or CloudFormation allow you to recreate or revert infrastructure easily. Monitor and measure. Implement observability so you can see the effects of changes and revert quickly if needed. Prioritize security. Security must be integrated at every layer of the data engineering architecture to protect sensitive information and ensure compliance. Key points: data encryption. Always encrypt data at rest and in transit, using strong encryption protocols, e.g. AES-256 TLS. Access control. Use role-based access control, RBAC, or attribute-based access control, ABAC, to restrict data access. Secure authentication. Implement strong authentication methods, MFA, OAuth, SSO, for all users and systems. Network security. Use firewalls, VPCs, private subnets, and VPNs to secure network traffic and isolate environments. Audit logging. Maintain detailed logs of data access and system changes for traceability. Data masking and tokenization. Protect sensitive data by masking or replacing it with tokens in lower environments. Apply least privilege. Always grant the minimum level of access necessary to reduce risk. Regular security reviews. Conduct periodic penetration testing and architecture reviews to find and fix vulnerabilities. Patch and update. Regularly update software, libraries, and systems to fix known vulnerabilities. Compliance awareness. Stay aligned with regulations like GDPR, HIPAA, and SOC 2 to avoid legal and financial penalties. Embrace FinOps. FinOps, financial operations, means managing cloud and infrastructure spending in a way that maximizes value while controlling costs, especially in dynamic environments. Key points: track usage. Use cloud cost management tools, e.g. AWS Cost Explorer, Azure Cost Management, to monitor usage. Set budgets and alerts. Define budgets and configure alerts for overspending or unusual cost spikes. Choose the right resources. Use right-sized instances and auto-scaling to avoid over-provisioning. Shut down idle resources. Automatically turn off unused compute resources or services when not in use. Use reserved instances savings plans. Commit to long-term usage to get discounted pricing on cloud resources. Monitor data transfer costs. Be aware of egress and inter-region data transfer charges. Tag resources. Implement a resource tagging strategy to track costs by project, team, or environment. Optimize storage. Move cold or infrequently accessed data to lower-cost storage tiers. Share accountability. Make teams aware of their costs and encourage responsible usage. showback, chargeback models, regular reviews, conduct monthly or quarterly cost reviews to assess savings opportunities and adjust budgets.